Okay, I think I'm sold on the moon thing. What about Mars? We got a lot of material on Mars. We've been staring at Mars for a couple hundred years and lots of mythology around it. And it just so happens I found a few videos that cover Mars. Let's take a look.
We are about to visit another recent historical site. This incredible gash is the Valles Marineris. Nothing this spectacular exists on Earth, on the land that is. You'd have to go into the ocean. The Grand Canyon would quite easily fit into the Valles Marineris. On Earth it would slice Texas asunder. This baby is big. Let's take a closer look. You could fit the state of New York in this gigantic rift. It spreads far to the east and west, cracking and shifting and wrenching the tectonic plates apart. This opening is in fact the width of the United States of America. Even so, it is a recent historical opening and ideal for our example. We will close the Valles Marineris. We will close it tectonically. That is, we will slide the tectonic plates back together, back to the position that they started from, and we will seal up this stretch mark without using any tricks. We are simply pulling all the pieces together according to a logical and sensible path which is dictated by the shapes and objects as they exist. We are not changing shapes by shrinking or enlarging or deforming them. We are simply moving them back together. If these pieces were worn away by water or by erosion of some sort, they would never again fit together. Yet, as you can see, they do fit together just about perfectly. When I first saw this process complete, I was stunned. I watched it for 2 hours in near disbelief. Please look at it as carefully as you can. This isn't a movie special effect. We are using the very best photos of Mars available and sticking to a strict set of rules. NASA, using radar scanning devices, has mapped the tectonic heights and depths of Mars' surface. By assigning colors to the various heights, a clearer picture emerges. Lower land is blue, then up to green, then yellow, orange, then red and magenta. Finally, a pinkish gray. Here, yes. I don't know about you, but I think this is fantastic. It's the Grateful Dead version of Mars. By separating the levels with colors, we are almost invited to slide these layers of plates together. As you know, these indeed are plates, that is, layers, like slate, like a cake, capable of being slid or moved apart and over each other when under strong pressure. If we move these layers back together, will the levels be assembled with each other? Let's slide these levels together and see if the colors reassemble on their levels. A warning, this couldn't happen unless Mars grew. Let's go forward in time. Now a comparison. The lower tectonic plate, the blue plate, begins back in time hidden, only to be revealed as a new lower plate. With, as you can see, no new craters. Am I tricking you and finagling with this map? Nope. You can see it clearly. You can see what we're doing frame by frame. This cropped off picture is Mars. I wasn't able to get the whole picture, but this will do for our purposes. The colors from NASA are not true. The colors represent heights, tectonic heights. The highest land is red. Down the rainbow, red, orange, yellow, green, blue. The lowest, newest land is blue. Why do I say newest? Because the upper higher land pulled apart and revealed the underland. Call it the newer land. Why newer, and how do I know? Actually, all scientists know. Look at the craters. As time goes by, for the older land, you get more and more accumulation of craters. This higher red and orange land is older with lots more craters. This green to blue land is newer with far fewer meteor craters. So it's younger. This is the Valles Marineris. I've focused on it because it's the greatest, deepest, and newest rifting and spreading on Mars. This rift is as wide as the United States, but you see, as Mars grew, this rift pulled apart all around. This pulling away made a big circle of pulling apart. The relief of this spreading that made this possible is the young, new, blue area. So quite simply, to go back in time, we close back over this blue, young area, and the upper plates will tighten back around this upper Valles area, and even the Marineris will close. The blue young area disappears, covered by the older land. Now we can go forward in time as Mars grows up to today. The blue opens and the land tugs, and some pieces break off into, well, islands if there was water. There is no other way that this plate area could come to this configuration unless Mars grew.
Let's do the whole planet next.
As we pull out to view the full planet, I'd like to prepare you for our next demonstration. As I implied before, science can identify older, higher tectonic plates or areas on, in this case, Mars. The upper plates are darker in color to begin with. Sometimes they're not. Then they, the older surfaces, have a great many more impact craters, which take time to accumulate. The lower, newer plates, conversely, have way fewer impact craters, and they are conveniently lighter in color for the most part. More recently, scientists have identified with radar scanning equipment those areas which are upper tectonic or higher elevated and older areas, and those areas which are lower tectonically. The darker areas are nearly always higher. The lightest, however, are always lower. The big tip-off is more time makes more time for meteors to crash into Mars. The newer the surface, the less time for meteor hits. We call this area the T-shirt. It is also called Acidala Planitia. I hate these Latin names. Check out the craters. Uniquely, though dark, some spreading has taken place, smoothing out some cratering. However, over here in this area we call the tombstone, it's extremely heavily cratered and dark mineral deposits coated. This is clearly upper tectonic land. Think of it as a continent. This land up here is lower tectonically. Younger, identified by scientists as younger. There's a piece of broken away upper tectonic plate in the middle of this lower tectonic plate. You see the old impact craters? Do you see how few impact craters there are up here? Above this, closer to the North Pole, the land is clearly and obviously thicker again, and heavily cratered. Come look over here past the T-shirt. Look at this fantastic lowland spread. Big and so far spread, and it's more medium in tone. It's youngish, but aging. Down in this southern area, we have a vast expanse of upper tectonic plate. The color is medium to dark, and impact craters are abundant and pervasive. It's like an orange outgrew its skin, and so the skin broke to let the orange expand. In Mars's case, most of the skin remained at the southern hemisphere. On Earth, most of the skin remained on the northern hemisphere. Mars relates to Earth, but upside down. This is a very, very new spread, way low tectonically and very light in color and practically unmarked by craterization. As we go up north, observe these stretch areas. We will soon unstretch them in our example. Now we're in a vast stretch area, which connects with the area we saw on the other side. Here's a curiosity. A piece of upper tectonic land, actually a few pieces, stranded in the middle of this vast spread area, like an island stranded in the ocean. Of course, we will try to find their original connecting tectonic coasts. Now we will watch Mars, the whole planet, go back in time. I'm going to ask Zia to provide a dotted line so that you can keep track of the start size. The upper tectonic plates move together as the planet gets smaller. This cannot happen unless the planet began small